Algebra 1, number 3.6. This is the only video for 3.6. There's no A, B's, or C's or anything. We're just going to clear away the fractions and decimals from an equation. Going to get rid of those pesky fractions and decimals. So, this is what we do. When we see fractions in an equation, we can use the multiplication property of equality to make the equation easier to solve. We multiply both sides of the equation by the reciprocal of the fraction to make our friend, the invisible one, identity property. So just like we've been doing before in the previous videos to solve, all we have to do is multiply each side of this equal sign by the coefficient's reciprocal. So the reciprocal of 1/3 would be 3 over 1. So we're going to multiply both sides by 3 over 1. That's going to give us 3/3 on this side, which is our friend the invisible 1. See, he's right here. Can't see him, he's invisible. And that means 9 times 3 is 27 over 1. So x equals 27, all right? And don't forget, I'm going to have some helpful video links in the description of this one for anyone who has missed like what that is, or, if you kind of come in this in the middle of nowhere and you don't know what I'm talking about, there'll be links to help you out, okay? So this is helpful when there's several fractions too. Now, we don't need to multiply by the reciprocal here. We can just multiply by its least common denominator, okay? So let's say we had 2/3 a plus 1/2 a plus 5/6 plus 2a. And they all have different denominators, don't they? So we can't even combine these like terms until we get the denominators the same. All we have to do is find the least common denominator. And we do it for each one. We don't just do it for one side of the equal sign. We look at all of the denominators. And a 3 and a 2 and a 6 can all meet at 6, can't they? That could be their common denominator. So that is what we're going to multiply both sides of the equation by a 6, okay? And you could technically say that it's a 6 over a 1 if you want to look at it that way, because that's still 6, right? So we get 12 over 3a right here, plus 6 times 1 is 6, and 1 times 2 is 2. We get 6 over 2a here. And we do the same thing to this side. We distribute it to this side. And we get 30 over 6 plus 12a. See? Now we combine like terms and simplify them. 12 over 3 is a 4a. 6 over 2 is a 3a. 30 over 6 is a 5. And we drop down our plus a. The fractions are all gone. Look. Looks simpler now, doesn't it? We combine these. We get 7a is equal to 5 plus 12a. We need to get the a isolated on one side of the equal sign. So we can subtract this 12a from this side and create a 0 pair, can't we? And that gets rid of it. Now we just have 7a equals 5. We can use the multiplication property of equality and multiply both sides by the reciprocal of this coefficient, -5, which would be -1/5. It's flipped upside down. And we get a positive, because that's a negative and negative, we get a positive 5 over a positive 5a, and we get a -5 over a -5 on this side, which is a -1. We also could have just taken the -5a equals 5 and just divided both sides by this coefficient, -5, and we would have gotten our -1. Couldn't we have done it quicker? All right, now, if we want to clear away decimals from an equation, we multiply both sides of the equation by an appropriate power of 10, one that's big enough to remove all the decimal places, but the smallest one needed. So let's take a look at this. We've got 16.3, that's one decimal place, minus 7.2n, that's got one decimal place, equals a -8.18. That's got two decimal places. So that tells me we're going to have to multiply by 10 to the second power as 100. That's what 10 to the second power is, remember? And that'll clear them all away. So we need to get one that's big enough to remove them all. So that has to have two zeros, right? As 100. But it's the smallest one needed. Because if we start multiplying by 1,000 or 10,000 or 100,000, it's going to be too big for us and it'll be silly, okay? If we only had -8.1, we could have multiplied by 10 because that would have been big enough for one place, and one place. But because this sassy guy has two places, we're going to have to do it by 100. So we multiply each term by 100. We multiply the 16.3 by 100, and that moves the decimal place 2 hops. 1, 2, and we get 1630, and now the decimal point's back there. See? We multiply the 7.2n by 100, and it moves 1, 2 hops, and it moved from here back to here, and now the decimal place is way back there, and we got rid of it. And in the negative 8.18, it moved 2 hops, and now it's behind the 8 here, way back here. So now this is our new equation. 1,630 minus 720n equals a negative 818. Now we need to get the variable to one side, and the first thing we can do is create a zero pair with the multiplication property of equality by subtracting 1,630 from this side and from this side. Remember, when you're subtracting integers or rational numbers, you add the opposite. So we're going to, instead of subtracting a negative 16, we're going to add a 1630, okay? And that's going to give us a 2,448. And on this side, we just drop down our negative 720n. Now, we've got negative 720n equals 2,448, and we can divide both sides by this negative 720, this coefficient, to simplify it. So how many times can 720 go into 2,448? Oh my goodness, it's a big number. Well, how many times can 700 go into 2,400? How many times can 7 go into 24? See? We'll just take both of those zeros off the end of both numbers. See, that has 2 zeros and that has 2 zeros. How many times can 7 go into 24? 3. So let's try 720 times 3, and we get 2,160. So now I can do my long division. 720 goes into 2,448 3 times, and because we put it into the whole number, we're going to put it above the 8 here. And we multiplied it and got 2,160. We subtract that and get 288. And I had to add a decimal point and a 0 because of this 288 remainder. We drop that 0 down, and 720 times 4 is 2,880. So that's a 4. We get 3.4 as our answer. See? So our answer ended up getting a decimal point back in it, but it made it a lot easier for us to multiply these by 100 to each separate term. So you can do that. Just write a little 100 over the top of each one. And if you have to use your little bouncy arrows to help you count the decimal places, if this said 1,000, then it would be 3 bounces. If it said 10, it would have been 1 bounce. You bounce however many zeros you're multiplying by. Okay, so 100 has 2 zeros, so we're going to do 2 bounces. 1, 2. And that means a 0 needs to go in here as a placeholder, right? As a 1630. All right? So that's how you get rid of fractions and decimals. Isn't that great? Makes math a lot easier when you don't have to deal with those, and you can just do your math straight across, right? Okay, we're going to move on to 3.7a. We're scooting along, and we're well past the midway point for Chapter 3, and we're getting close to Chapter 4, all right? I'll see you in the next video. Bye.